Hello everyone, this will serve as an introduction to matrices, which we first see in section 3.5. So let's take a look at what a matrix is. A matrix is a rectangular array of numbers in rows and columns, and we'll see brackets around these numbers. Now we'll use matrices for a number of different things, but the main thing that you'll be interested in is the fact that we can use these to solve systems of equations, and it makes solving systems of three equations and three variables a lot easier. So a little bit more about matrices. The dimension of a matrix follows the pattern of rows by columns. So a 3 by 5 matrix has 3 rows. Remember, rows are horizontal, and 5 columns. So it'll look, it could be any numbers at this point, so we're just talking about a general 3 by 5 matrix. I know that there's going to be 15 elements though, and elements are just the individual numbers within my matrix. So I could have 1, 2, 3, 4, 5, 8, 9, 10, 4, 3, 2, 1. Elements can repeat. That's just one example. We have 3 rows and we have 5 columns, so that's just a random 3 by 5 matrix. Two matrices are equal if their dimensions are the same and the elements in corresponding positions are equal. So something that would be also congruent to matrix A would be if we saw another 2, 5, 6, 0, negative 3, 2 matrix, let's call it matrix B or something. Notice we are naming matrices by a capital letter, so this is matrix A, this is matrix B. So in this case, what are the dimensions for matrix A? Well, remember we have rows by columns, if it helps, RC Cola or RC car or anything that you can think of that R and C kind of go together in that order. So how many rows do we have? We have 1, 2, 3 rows by 1, 2 columns. So the dimensions for matrix A are 3 by 2. And it may seem trivial, but especially when we get into deeper operations with these, it's going to be very important that you are able to find the dimensions of any matrix. Because sometimes when we're multiplying, you can't get an answer out of it. Adding and subtracting matrices, very easy. You add or subtract the elements from the same location, and your matrices must have the same dimension. So here we have a 2 by 3. Here we also have a 2 by 3. So we're free to add and subtract. So when we're doing A plus B, we're just looking at the numbers that are in the same spot. So 2 plus 7 is 9. 5 plus negative 3 is 2. Negative 4 plus negative 10 is negative 14. 1 plus 1 is 2. Negative 3 plus 3 is 0. Negative 2 plus negative 9 is negative 11. So that's A plus B. Notice how it also has the same dimension as A and B. We're also a 2 by 3. And then A minus B, same idea. We're just subtracting instead. So we've got 2 minus 7, which is negative 5. 5 minus negative 3, which is going to be 8. Negative 4 minus negative 10 is going to give us 6. 1 minus 1 is 0. Negative 3 minus 3 is negative 6. And negative 2 minus negative 9 is 7. So we're just going element by element. Seeing in this one case we added, and in another case we subtracted. And we can also multiply a matrix by a scalar. And what's a scalar? It's just a real number. So essentially we're distributing, in this case, a negative 3 to every element within A. So I could put a negative 3 out in front. I can rewrite matrix A. So I want to distribute that 3 to everything on the inside. So I've got first negative 3 times 1 is negative 3. Negative 3 times 4, negative 12. Negative 3 times 3 is negative 9. Negative 3 times 9 is negative 27. So If this is matrix A, this is matrix negative 3A. And again, we just multiplied bit by bit. That's all we're going to talk about for today. We're going to do some more practice with this in class, and then we are going to go into multiplying, and we can't divide matrices, but we can do inverses, and then we can see how useful this can be with solving systems of equations.